Okay, so today we have Christian here to help us go over some stuff with Parquet. He's going to go over the big picture and some history things, and then I'm going to go over some of the more detailed stuff and show you how to use what Christian has implemented in Deephaven. So that's the plan for today. The goal with this is that you will understand a little bit about Parquet, and you can troubleshoot some of the problems that might come up with some of the devs in the future. If you have questions, just ask as we go, of course.
Cool. So the Parquet history essentially starts with this little paper from Google, Dremel Interactive Analysis of Web Scale Datasets. And I have the link in there if you want to go to the paper. It's a little bit technical, but it's interesting. We're going to skip the next two slides in the benefit of time, but if you want to go back to them later, there is a nice picture of a dog in a Halloween costume to motivate you to, take a look. But anyway, to the actual thing.
That may be the most interesting slide there.
And I assure you, it is relevant to what I'm saying in the previous slide. So, cool. If you remember from the presentation that Colin and Nate and you guys discussed before, protocol buffers, they are going to be relevant for our story of Parquet, so I'm going to do a little bit of a recap of them, okay? So this file here in this slide is taken from Deephaven Enterprise. It's a definition of message in a proto file, extension.proto. Protocol buffers, protobufs, or protos for short, are a binary format, right? And you see them these days most of the time as a way to send messages from client to servers, right? They look like a schema definition of sorts. Its message is a record, and you can see there some types and names for fields, and the fields have a positional indicator too. They are numbered 1, 2, 3, etc. Right? Two things that I want you to note in this file is that the last one for the first message, the last one for remote processing params, says repeated. So we have the ability to send fields that are not dimension 1, but there can be multiple elements like an array. If you were making a function call, that argument there will be an array of elements, okay? And the second thing to note is that, as you will expect in something that is trying to emulate a function call, but from one computer to another, when you make a function call, you typically can pass an object, not only primitive types. So the second one, add job request in there, has an element of the first type. It has remote processing params as the last element. So nesting is going to be part of the story, and the way that Google actually handled data and the fact that that data was heavily nested influenced the fact that Parquet has good support for composite types, for nesting types. Actually, I am actually going to make a statement later. I'm going to say the support is too good. You most of the time really don't want to make your data look too much like this, because you actually get in trouble if you do that. So cool. If we can go to the next slide. So protocol buffers, you see them today in things like gRPC and sending messages from client to server, but they are also used, they can be used to store data on disk, like having a file in a structured format with records on them. These records mostly look like row-oriented, right? You have one binary string after another in this structured way, and you can have programs writing them and then a different program reading them, and they can agree on what the bits mean. And Google, and this is the important part for the story, protobufs is the universal data language at Google. Everything that is stored in Google in terms of data for jobs doing some kind of work, I mean, the web crawling that is done for building the index, attributes for YouTube videos, everything is stored somewhere as a protobuf. The somewhere sometimes is the local hard drive temporary space in the virtual machine where they are running. Sometimes that somewhere is a distributed file system like the Google file system thing, where you have a well-known location that doesn't disappear when the process stops running, but everything is protos, right? Given that most data sets are protobufs in Google, the typical way to do analysis early in Google was just to do a map reduce over these protos, okay? You guys probably know what a MapReduce is. You have, these files sprinkled across multiple machines. You need to do some kind of computation on top of them. You go to each machine having a proto, do some local computation there, probably do some aggregation or something like that, and then do a reduce phase where you get your answer, right? Given the number of machines, given the amount of data, the expectation was that an analysis like this, a MapReduce job running, will take hours, right? So what you will normally expect to do is that you will prepare your MapReduce job that actually implied coding, right? Writing a program, right? You will divide it a little bit, try it on a small data set to ensure that your program runs, and then you will let it run over however many machines you actually had to run them to get all the data you needed. And that was going to take hours, so you probably went home and, next day in the morning you had your results if you didn't have multiple clusters. If you have multiple clusters, maybe you came back to the result after the weekend or next week, right? For the smallest sets, it could take minutes if you didn't have, hundreds of thousands of machines, if you only had hundreds of machines. But still, minutes is not the type of thing that you get an interactive answer, right? It's not something where you type a query, press enter, and just wait a few seconds and see an answer on the screen. It's more like the type of thing where if it's going to take minutes, you press enter and you stand up and go to the kitchen and make yourself a coffee, right? So the motivation here for Parquet and the reason Google came up with this format, which later was called Parquet and standardized by the Apache Foundation, by the way, for one project of theirs. If you look at the paper, it's not called Parquet, the format in the paper, but it's the same format, the same idea. And if reading the Apache Foundation documents for Parquet, it references the paper, etc. The motivation here was, well, we actually would like, in some cases, to have interactive data exploration, and we would like to be able to look at the data to try to discover properties of the data and explore, and this cycle time is not really good, right? I mean, having to wait for hours for a response, and just because I'm kind of like designing the right type of query because I don't really know what I'm looking for, that's the whole point of me doing the exploration, that use case didn't work very well. So Dremel and Parquet, Dremel is a tool, Parquet was the format created so that tool could work, came in as a way to try to solve that problem. Next slide, please. So the basic idea, could you go to the next slide? Thank you. The basic idea behind Dremel is one less, sorry. One slide back, yeah. Thank you. The basic idea of Dremel is we are going to move from this protobuf format, which is essentially row-oriented, and we're going to make that column-oriented, right? We're going to move to a columnar folder, right? This idea in particular is not novel. You guys may have discussed this before, right? There is the notion that for doing analysis, storing data by column is a better way because it enables vectorization. It gives you the ability to see all the values for a particular field next to each other. So when you need to do things like, computing and aggregate, I need to sum all of the values from the point of view of the work that the computer needs to do. You have all the values right to each other in memory. You can quickly do that instead of having to do things like, oh, I need to do an addition on the field quantity. But the field quantity is in the middle of a big record that is 300 bytes long, and to go to the next quantity in my for loop, I need to move to the next 300 bytes, which creates cache localization problems and waste of memory, etc. Right? So that's a win right there. It's not a win that Google invented, but it's a win that they knew they could get if they transform the data. So they did that. The second idea is that on top of that, we're going to run a distributed query engine to run SQL-like queries. This whole protobuf thing and MapReduce is the NoSQL world, right? We don't have a query language, we write code. We have to write a program to do this. The idea behind Dremel is we want a tool where you actually want to be able to explore data. You want to be very quick in being able to change your query. So you want some kind of query language. Why reinvent the wheel? Let's use SQL. But we don't have a relational database behind the scenes, an actual relational database engine we are doing this novel thing where we're just running SQL on top of a bunch of files. Lots of files, but on top of a bunch of files. There is still a map reduce phase here because essentially you need to take all the existing protobuf files and convert them to this new Parquet format. And that phase can take hours. But the good thing is that once you do that once. And after that, you can run the interactive queries because they run much faster, fast, and as many times as you want because the Parquet files are already generated. So that's pretty much it. That's the origin story for Parquet. I don't want to take more time of this presentation for this history part. I think we want to go to the more technical tidbits part with Amanda. So I'm going to leave it here. Okay.
Okay. Thanks. So that's a really good history. Parquet came out in about 2013, and so it's been around for about 8 years. So it's adapted quite a bit in that time, and so there is a lot of consequences with kind of the history and how it's evolved. So what we're going to go over now is kind of what you'll see when people are using Parquet formats. So this is from the Tech We Use slides and kind of a motivation for why we're looking at Parquet files in this format. So if you remember, we use this Apache Arrow, and that's essentially a middleman between a whole bunch of data formats. And the Arrow is much like Parquet, but it's considered the in-memory rather than on disk. And so when we're writing on disk, oftentimes we'll use that Parquet. So most of this is going to be through the Apache Arrow versions of the Parquet, which works with most Parquets. And we're going to go over only a few of the specific ones. So when you're using Apache Arrow, there is a lot of compatibility. This works with Hadoop, of course, and some of the other things that you'll see it with is Drill, Hive, Impala, and so forth. I have this slide here because this has a whole bunch of links to those software. So if you want to see the specifics on how they use Parquet, then you can click on the links. There is also a C++ implementation that JJ you can play around with, and that is part of Arrow. So that'll be fun for you later. So we've gone over this slide a little bit before when we learned about the columnar data. Now it's a little bit more hairy than we've gone over in the past though, because with Parquet data, we think of it as the columnar chunks. But before the columnar chunks, there are these row groups. Now, one of the reasons why it's almost always the same is the default is that the entire file is your row group. And so you can think about it as most of the time a whole file is a row, and then that's broken down into chunks, and that's broken down into pages. Now, pages you can think of as those individual non-divisible units. So what really matters with Parquet files is how we decide on row groups. There's two different versions of Parquet files. There's a whole bunch of different compressions of Parquet files. And then there's options to set the page sizes and dictionaries as well. So these are the ones we're going to go over in detail.
So are the page sizes hard-coded into the files, or is this just a read time thing?
The page sizes are something that you can write into your Parquet file. And that's something that the user is going to want to change based on how they want to compress the data.
So can you explain what the page is then?
So the page would essentially be, and I'll go to this one right here. So the page is going to be the chunks inside the column blocks that essentially are all read at once. And so the pages are what's compressed inside each codec. And so, for example, if you probably want to have the page that's all similar data, and so that you can compress that more efficiently.
Okay. It's also the minimal unit that you can read in one. You can think about it also in terms of is the minimal unit that you can read coherently, because you cannot get in Parquet terms to one element of a page without reading the whole page. But you don't need to read the whole chunk. You can read one page.
Okay, but these sizes may not match the OS page sizes?
They don't have to, no.
Okay.
So here are all of the the parameters that we're going to go over for how people will write the Parquet files to a disk. So the first one is the row group size. And so what we have imagined before with the row groups is kind of like this image on the left, where the file is divided up into just columns. But that's not always how you want it, because some of the Parquet files can be like 50 gigabytes. And when you're writing these files, you really want to think about how the row groups are spanning the disk blocks. Specifically, you want each row group to fit on a disk block so that you can have essentially a better latency when you're reading each row group. And you could think about on this picture on the right, in the most extreme, if you have teeny tiny row groups, then you're not actually using the benefits of Parquet's column format. So people will change this depending on the disk blocks they're using and the sizes of their row groups.
So that's tunable, the row group size?
Row group size is very tunable. And all that we have to do for that, notice it's one of the first things to tune. The default is all of the rows are going to be just inside one row group. And this is a megabyte parameter that you can specify that row group size.
Note here, though, that in the title of the slide, there is a day. Just to be super clear, this is not Deephaven.
No. So this is when you're taking in a Parquet file. It's oftentimes nice to see kind of what that Parquet file is, and when you're reading it into Deephaven, why it might be read in a certain way. Okay, so the next parameters that we're going to go with are the version, which is the second parameter up here, and that kind of sneaks its way down into a whole bunch of the other settings, like the data page version, and then how Parquet looks at timestamps. And a lot of this Christian has already programmed behind the scenes, and it was rather troubling, it seemed, because there's nuances with especially 96 that are really complicated. So version 1 versus version 2 of Parquet. I thought this was really cool. Parquet 2 and Parquet 1.9 and onward, they use something called logical types of data, which is the data is based on just these 5 primitive types of data. So we have Boolean, binary, 32-bit integer, 64, and 96. And everything else is essentially a reference to just these primitive types. So that was pretty cool, and that's also a memory saving way to do it. So when you're looking at strings, strings are actually binaries rather than a string. Lists are going to be 2 different of the primitives and so forth. Now, the default version when Apache Arrow writes Parquet is version 1, but you might want to have a data page version 2 so you can use these primitive types. So version 1 is going to have that maximum compatibility, whereas version 2 will be a little bit faster in the read and write. The other difference is how they serialize the data. Okay, so a little bit more about kind of how they do the time. Parquet 2 uses what's called delta encoding, which I didn't know of until Parquet. And what that essentially does is it references the change in the data. And so they do it this way because if you think about it, we have, for example, 2 60-minute candles. The difference with 60 minutes can fit into 1 byte. And so you can see that up to 255 minutes will fit into 1 byte, and hence the use and applicability for this delta encoding.
So,
Now,
do you specify delta encoding per column, or is that automatically determined, or is it applied to everywhere?
That one is automatically inside Parquet 2. Okay.
And so for something like doubles where there's funny business when you do deltas in addition, how is it handling that?
So I'm not sure how it would do that.
My assumption is that essentially a 64-bit representation for a double, for instance, or a 32 for a float, when you look at the bits.
Okay, so it's just doing it bitwise?
Right, right.
Okay.
And you know, whether the result of delta encoding will give a good compression or not is totally going to depend on the values, right? But that is going to be looking at the bits as values, not as a double value, right?
Well,
That's a
wait,
guess,
no.
by the way. I'm not 100% sure what I'm saying, but this is my guess.
But it says delta encoding is used for timestamp columns. Is delta encoding used for other data types as well, except aside from timestamp?
I think so. Yes.
Oh, okay.
There are ways to specify different types of deltas too in more modern version of Parquet. Some of them are actually kind of like, you know, in beta. And tools like Impala use some things that we have recently discussed in the engine as ways to compress sequence of integers that are sorted, for instance.
So the data encoding might give you a lot of savings in space, but what about the time needed to, decode?
It's super fast,
Then,
right? Because essentially you are taking the difference between values next to each other. We live in a world where moving data from one section to memory to another is considerably slower than what the CPU can do. So even when you think about a lot more complicated compression schemes like LC4, right? LC4 actually accomplishes memory bandwidth speed. So you can have something LC4 compressed in memory, and you will not notice, unless you have other work on the CPU happening that need the CPU, of course. But from the point of view of the absolute time that it takes for the data to move, you can move and decompress, and that will not be slower than just move.
So it sort of seems weird, right? Like we use delta encoding for these big fat columns, 64-bit, 96-bit integers, right? Because then the difference usually is a byte. It's usually a byte or two, which is way less than 8 or what would that be? 12 bytes, right? So that's how you have compression. That's you're storing what you needed in 12 bytes in only 1 or 2 bytes, right? But if you delta two doubles, the result is a double. So it's still 4 bytes or 8 bytes or whatever kind of double you're using. So you're not compressing anything. What are you compressing? You're not compressing anything, right?
Right,
So,
but the thing is that the delta encoding is not going to be applied. The delta encoding is not going to be applied arbitrarily, always yes or always no, right? The actual decision of applying delta encoding or not is hopefully being done by some platform for you, depending on the data, right? And this whole notion that you store data in blocks, right?
yeah.
Chunks that then are stored in pages, and you applying compression on a per page basis means that it's even better in the sense that if your data was very uniform for a while and then it changes, you can still compress the part that was uniform because that fits in a uniform page. But then the pages that start being not uniform, they just don't apply the compression.
Got it. Okay. So the answer to Chip's question is like maybe it doesn't do that kind of compression with doubles.
Well, and there's a lot of things that you could customize with it. How they, for example, in version 1, they used to cast the timestamps differently, which you can turn on or off, and things like that. One of the more interesting things I thought is that a lot of version 1 uses int96 timestamps, which were actually used with the Julian date, which this is the only software that I've seen use the Julian date, which was kind of an interesting thing. And going to Julian date is really hard, but it's apparently not as bad going from Julian date. So another really big one is the compression that's being used. The default compression is Snappy, which works with Apache Spark, and Snappy doesn't support any extra compression level other than what you already get from how the data is formatted. So I took a data file and I compressed it in a whole bunch of different formats so you can kind of see the compression differences just based off of integers and double data. And you can see that the none and Snappy and LZ4, those are bigger than the normal CSV file. And then the ZSTD, gzip, and Brotli, which I haven't heard before, are a lot better compression for the integer and double data. Depending on the type of data that you have, of course, will depend on how the data is compressed and what benefits you get. But those are the 6 type of compressions that you'll see, or lack of.
So as far as compression, you say that, I mean, yeah, so results of the compression will depend on the type of data. What type of data is in that ETH CSV file that's being compressed there?
Those are integers and doubles.
Also, one comment I hadn't noticed before, I should have mentioned this to you before, but that file is probably relatively small. I think we probably are seeing, the effects of overhead here, because I would not expect to have a CSV file smaller than a Parquet file,
Yeah, it's a good point. So as far as which compression codecs work with Deephaven currently, if you take a Parquet file and it's either uncompressed, snappy, ZSTD, or gzip, it will most of the time work in Deephaven, unless you're using the data page serialization 2. And so that's something that you can pull from this file when you look at it via a tool that I'll show you later on. And as of right now, you don't want to play with the row group size in Deephaven because there'll be some errors occasionally.
Okay, so I guess I have just a question on our support here. Is the plan to fill this in quickly, or should we provide a tool that will look at a file and say whether it's supported or not?
We should support all the compression formats in there as part of the June, how are we calling it? Sprite, or whatever. Epic, that's the name. So yeah, and I believe the problem with the R2 column has to do with the version of the Parquet library that we're using. I have a branch where we are updating that to the latest one. I need to test, but I hope to remove that incompatibility there too with that. So as of right now, I believe we can support all of this without having to make a distinction that like the one you were describing.
Okay.
Okay, so the next one that we're going to go over is the page size. And so the default value for this is, I believe, a megabyte, and you could specify it to be different in the system. Oh, there it is. That's how many bytes. And so this is kind of another way of viewing how you see the page sizes. And just the best way to think about this is you can read in one page at a time. And so that is the chunks that you're really compressing. Okay. And then the last 2 bits are, one of the cool things about Parquet is you can specify whether it uses a dictionary or not. And so, for example, if you have a list of strings, you can put in some dictionary encoding to save you space. And so here you can see is the uncompressed, which with the dictionary encoding, you will save a little bit of space.
We have a problem right now, and Paul discovered this while working with data for a customer in Deephaven Enterprise with handling of the dictionary encoding, because you probably know that Deephaven itself, the engine, uses some notion of a dictionary encoding internally too, to represent the string columns and things like that. It's not always like that. You can select it, but it's a good default for when you have fields that repeat very frequently, like the stock symbols in trading, right? But one problem that we have right now is that when you read a Parquet file, the dictionary encoding between chunks can switch on and off, and the support that we have in Deephaven doesn't consider that. It only selects one at the engine level, and if it changes, it just stops working. So we need to fix that too. Ryan is going to be looking at that.
Well, and it's really cool because you could specify the dictionary page size. And so you can imagine if you have a very small page, then you might see more repeats than if you have a really big page where there's a lot more data. So that's another thing that's tunable. And
what is a dictionary? I'm a little confused.
You can think about it as like an enum list almost.
Oh, okay. I see.
So imagine that you have the stock symbol Microsoft MSFT, 4 bytes, right, as a string, 5 maybe with a terminator. and many of your executions are Microsoft, right? So if you just assign an ID to that, you may be able to represent that in less space.
Got it.
And so the last one is this nested version. And so Parquet allows nesting, which, like JSON and things like that as well. So Jinping's familiar with that. So on the left, you can see is a flat Parquet file. And on the right would be kind of the same exact file, just nested. And so it's essentially like a table inside of the table. And one of the benefits with this file is that the amount of memory that you use for that nested has decreased because you're essentially referencing something inside of something else, so you can save that memory. But computationally, a file that is nested is going to be a little bit harder to read into Deephaven than not. So going into using this with Deephaven, in Python, you import the table management tools, and then you could just do read and write like you normally would. With Groovy, you probably want to, at this point, use the full reference path because there was an import problem with the table management tools that we found the other day. And so that would be the command to read and write the data.
Table management tools used to be imported by default, so it didn't used to be the case that you had to specify the full path in there. We need to fix that. It's essentially a bug right now.
Yeah, but I expect the interface is changing shortly as well.
And then if you come across problems, I highly recommend that you install Parquet Tools. This is something Christian showed me. So to install Parquet Tools, it's just a quick brew install on the Macs. And then you can see the schema of Parquet files. And you could also see the data of the Parquet files with the cat command.
So you mentioned arrow in the earlier slide. Where does arrow fit in this picture?
So arrow is essentially what people are using to read and write Parquet files to use them with the in-memory. And so you take one of these platforms like Parquet and you load it into your arrow, and then you could do whatever you want with it, however you would want. And so the Parquet format is just that format that is essentially like universal for a whole bunch of things to go cross-platform.
So so go to the last slide. When we read the Parquet into Deephaven, we store it in arrow format, or we store in our proprietary data format?
Currently, our proprietary data format.
Okay.
And I think what Amanda was referring to as arrow is because the code that she showed earlier, where in that title of the slide, it said how they write, the they there is essentially the arrow packages for Python, right?
Yeah, and I think that's where most of our developers are going to be coming from.
Oh, okay. So if
from the point of view of like the repository and the source code of this, there is a strong relationship between Parquet, which is a format on disk, right? It's a file format, and Arrow,
right,
which is a platform for exchanging data in a memory format that is trying to be universal across tools, so that different tools can exchange data with the same in-memory representation. One important distinction, though, is that Parquet and the way Parquet represents data on disk, and Arrow and the way Arrow represents data in memory, those two things are not the same, right? There is the need for serialization and deserialization when you read and you write Parquet from and to Arrow. And from the point of view of Deephaven, we read Parquet and we write Parquet from our own in-memory format at the moment.
I got it. Okay,
so
there could be
our memory format to Arrow or not, but I'm not current on those, so I'm not going to talk about that. That's why I say at the moment.
Okay. Any other questions?
Yeah. So I have a question. So I have not used our Parquet stuff, but I've played with Parquet and Julia. and I've created data frames. I've written out, I've read it in, I've compared a bunch of other data formats. And I guess my experience there was that the performance of the Parquet stuff was pretty terrible. So it wasn't something that just worked out of the box. It seems like there are a lot of knobs that need to be turned.
Ouch.
Can you guys talk about what what important knobs to consider are? How you could get into poor performance.
So I mean, right now, right, our intention so far from the Deephaven side has been to give you transparent. It just writes and reads. You don't need to say anything else, right? And we don't have a basis of comparison to know if it's like very slow or not. I will be interested in understanding when you say that your experience was very slow there. Two dimensions: one, compared to what, and two, in which particular platform were you working? Because Parquet has been through a lot of revisions and changes, right? But again, going back to Deephaven, right? Right now, we actually have 0 knobs on the Deephaven side. We are using the defaults from the library, and I think there is some work that Brian and Radu, former Deephaven employees, did there to auto-tune, right? But there has been no work in looking at that again. We're mostly wiring in the format. We're not looking at performance right now.
Well, and I would like to add to that the Parquet side, there are a lot of knobs to tune. There's almost another half of these knobs in the specifications that you could tune. But once they get the data into Deephaven, then they're going to see that performance boost. And so we can't control kind of the pre-knobs, but once it comes to us, it's using the power of Deephaven. So.
Yeah, I guess I have multiple concerns, and one is just, we have the speed of our stuff, which we have some control over, but at the same time, we may have users creating files through some other mechanism like I was doing and end up with a file that just sucks. And us as a DevRel group have to be able to explain to them why it sucks and what they should have done.
Yep.
That's an interesting point for sure, yeah.
Well, and hopefully now people understand the background of how a file can suck. It's a better way to put the 4 point. To change the 4 point.
The other thing, right, is that I think there are multiple implementations of Parquet. It's not hundreds, but it's also not 2. And the most current one should be the one in the GitHub repository for Parquet MR for Java and the Arrow repository for C++, right? I think some tools actually evolved in a way where they have their own Parquet support. I don't remember which ones, but even some in the Apache ecosystem, right? Some of the ones in the list that Amanda had in, that slide. So one thing that is probably interesting here is which particular tool the file came from, and does that tool have a current library with up-to-date Parquet support versus a library that was up-to-date 5 years ago, but that didn't continue evolving as Parquet evolved,
So far, I've used the C++ implementation to write files and the PyArrow implementation to write files. And both of those are compatible with us pretty well. I really want to play with the Athena one just because all of the other ones are inside the Apache realm, but Athena is inside the Amazon realm.
That one file that you shared that had the in96 timestamps and the strings as binary, was that also coming from PyArrow?
No, that was a C++ implementation.
Okay. Yeah, one interesting thing there is that for very old Parquet, when you actually read string columns, the file itself doesn't say string. There's no logical type string. You're just reading binary in from the file. And there is nothing in the file itself that tells you that that's a string. You actually need to do the conversion from binary to string after you read or as part of your read. So that file that Amanda shared with us to help us test, right? When I load it in Deephaven, those strings actually show up as byte arrays, and I have to apply a conversion in Deephaven with a view on top of the table to get the strings out of the byte arrays.
I think it was this one. No, it was this one. And so when you're looking at that, the string is listed as the binary month of order date. And when we have that same file and cat the file, oh, it didn't work. But that's because the binary didn't transfer right.
We are also adding support to other mapping because Deephaven does not support spaces in column names. So when we read that file, what we're doing is that we're converting the spaces to underscores by default. And we're allowing you, since we need to do that, we're also allowing you to specify any other column name mappings that you want with a new API that is going to be in the next version once Ryan and myself and the review and merge that.
Okay, so are you gonna have to do other conversions, like people put $signs or other weird stuff in there?
I think we need to essentially discover what is common, and as we do that, add those as automatic conversions, maybe with warnings, you know. But at this point, I have no base to guess which ones may or may not be common.
The files that I've seen that reference money do not have $signs in them, but I've only looked at like probably 20 different pre-made Parquet files so far.
Yeah, I don't know that I would start from what's common. I would look, you know, Devin years ago wrote a function to validate names. I would look at that and see what conversions we need to make and just assume that some user somewhere has done what we don't support.
Sure. Okay. Yeah. So essentially, you're saying if there is a character that we don't support, ensure that we map that to something reasonable. Okay. Yeah. Good.
Yeah. And we do have a function somewhere to check this, so
Okay.
that can tell you, that save you some time.
Okay. Cool. I'll look that up or ask them. Thank you.